Hey everybody, welcome once again to Rag Masters, a show about retrieval augmented generation. I'm Neil Katz, 20-year tech entrepreneur, and with me, of course, as always, the venerable, the brilliant Daniel Warfield, data scientist, rag engineer in his own right, and online educator. So we've got a interesting guest today, Daniel. I'm actually pissed off. I'm upset. I'm not happy we have this guest here today, actually. It's not because he's not a brilliant guy. It's not because I don't respect him. All that's true. But today we actually have our partner CEO of EyeLevel, the company that we all work for. And when I joined EyeLevel 2 years ago, I made Ben a promise that as long as I was here to help him run the business, he would never get to leave his basement again, because we need him in there developing and engineering more things. And you went ahead behind my back and called Ben and said, let him escape from the basement. I have no idea how this happened. Suddenly he's here now. So we're going to just make it short, okay? Because I need to building things. Jokes, obviously, Ben's actually the CEO of this company. I don't get to tell him anything, but I'm glad he's here with us today. So what we're going to talk about today, though, is really interesting. That's why we brought Ben in. It's really like, from my opinion, it's like, we debated what to call this video. For me, it's like the science of how to really do search right for RAG, how to really execute RAG search. And part of that is the search itself and what technology you choose. We've got some really surprising things to tell people today about that are really counterintuitive, what everyone thinks is true. And the other is how you prepare the data for search, which is just as important, maybe even more important, so that your RAG database actually can be searchable in an effective way to do RAG and get the right retrievals and the right completions. Does that kind of feel like it sums it up right where we're going today? That's my feeling of how we frame this up. But why don't you tell us what you think we're going to do, and then we'll bring Brent on and actually tell us how this works.
Yeah, I think, like, first of all, if you're a RAG engineer, buckle up, because this is going to be very different than what you expect. Like, all the conventional wisdom, not all of it, actually, maybe you'll only get conventional wisdom, and you won't get a lot of the flashy stuff that I think has kind of been pervasive in the industry for a while. I think there's a lot of cool stuff happening in the AI industry, but it's also very chaotic. There's a lot of mud in the water. And I think that it'll be surprising maybe how much clarity existed in technologies that are relatively ancient, and how it seems like maybe a lot of people are maybe over-engineering some things, or at least over-hype following some things. And this, I think, to some extent, will be a look back on older established technologies that I think maybe some people forgot about or never even heard of before, that are very performant. And, it's funny, we're forging these new trails, but maybe we should look back just a smidgen at some of the things that we already have created, and how can we integrate new AI technologies into those older strategies and potentially get something very performant. I'll let Ben really, I think, take the lead on that.
All right, so I want to rip the Band-Aid off. Let's bring in Ben from the basement. Hey, Ben, actually coming live from Ben's basement. Ben, how are you?
Daniel smuggled a camera in. I still have not left.
My pact to you has not been broken. Welcome, Ben. How are you?
Good. Thanks for having me on. Yeah, I don't know how much you guys have dived into the background of the company, but
not at all. Actually, we mostly don't talk about EyeLevel because Rag Masters is mostly a show not about us. It's mostly about how to do better RAG. But you make a good point. Today, we're just for the audience. We're going to talk a bunch about our own technology, not because we're bragging about our technology, because we want to use it as a door to explain some techniques that we think are really useful. So sorry, with Ben, when you go into it then?
Yeah, I think it's relevant exclusively to inform where our perspective on RAG came from. So our background, Neil and I met when we were at IBM. I started my career at IBM Research. I was in the building when they filmed Jeopardy with Watson. I watched the researchers leave the company and go join hedge funds. And then the company tried to create a product line from a research project and pulled anyone that had heard of Watson into the new product division. And I was involved with Watson from its formation, watched all of the good things and bad things, maybe more bad things than good things that happen. But really, a lot of companies were coming to IBM at the time, and the reason they created the division was people saw Jeopardy, saw what a talking computer that could answer your questions could do, that it was possible to fulfill that dream that I think every human has had for computers since computers have been invented. And they came to IBM with all kinds of ideas for how to apply that to businesses, a lot of which we're living through again now that ChatGPT is here. I specifically worked with a lot of consumer companies. They were interested in getting a Siri-like experience. Siri had also come out around then into their app, whatever the app meant, and just expose an ability to ask questions about the brand through a Siri-like experience. Anyways, as we built these out, the hardest part was getting them to talk about what the business cared about Siri talking about. And it was just a nightmare how it had to be done at the time. It was a lot of mapping of intent to responses, drawing trees. I'm sure a lot of people are familiar with these ways of teaching bots things. And we could see that it was just a struggle to feed in enterprise content into these AI technologies. We left in 2019 to work on that. One insight, I think, none of these insights are groundbreaking anymore, was that the majority of knowledge in a company is in unstructured formats, files on people's laptops or in cloud folders. And a tiny fraction of it is in what's called data lakes, in structured format. Businesses had spent a lot of money moving unstructured information into structured data lakes and had made marginal progress. Most of the information still lived unstructured. And so that became the focus. How do we take the pile of knowledge where it is and feed it into AI? We knew that a ChatGPT was coming because we had seen the trajectory that these technologies were on firsthand. We just didn't know when. When GPT-2 came out, OpenAI offered beta access to GPT-3, early beta access. You had to go through a fairly rigorous application process. We were tipped off by our investors. We got access and pretty early, somewhere around 2022, and immediately started doing RAG. So we didn't think of it as RAG. We thought of it as document search. And so everything we know and have created around RAG, we started thinking about pretty much in a vacuum in 2022, before there were, vector databases or best practices. And that's what really informed the approach we took and why it's so different than everything everyone else has done. And it all starts, the design of what we've done starts with, what do people want to ask these things about a business, and where do the answers come from? I'll pause there.
You were the least cool kid in the classroom, right? You were trying to do essentially these enterprise language-based AIs before ChatGPT.
We would twist ourselves into a pretzel trying to say we did not work with chatbots. So we tried to invent all kinds of names for it, like knowledge assistants and all kinds of crazy names that don't say chatbot, because if you said chatbot, and you were trying to raise money, as we did, that was an automatic no from any investor. We talked to 100 investors in Silicon Valley when we raised our pre-seed round in 2020, and 98 of them said no. And that's not an exaggeration. There was just a belief that the chatbot hype cycle was over, and chatbots were a distant dream. And were currently very annoying. And none of this is wrong per se. What was wrong was that a solution was coming that was going to fulfill on this dream that everyone, I think, has of asking a computer a question and getting an answer, and not having to browse and type and click and read websites.
Yeah. So why don't we, zoom in, fast forward a little bit. So ChatGPT is invented, and the whole society is off to the races now. And at EyeLevel, we have tools for doing advanced RAG, APIs essentially. There's also no code, but the APIs is more important for this conversation. But underneath the hood of those APIs is, I think, a fairly different approach to doing RAG that ultimately winds up being, in our experience, more accurate, sometimes 50% or more accurate than some of the other frameworks, because some of the assumptions that you've taken were different because you kind of built it before RAG had a name, or there was common wisdom about how to do it, which we think may not be even the right path. So I'd love for you and Daniel to get under the hood a little bit. And why don't you just explain how this is a different approach to RAG under the hood, and what techniques are you employing that get RAG engineers to much more accurate results, because you're doing things a bit heretically?
Well, the way I always prefer to explain it is the thought experiment we had to do in order to come up with a solution. And I started to describe it, but it starts with, what are people wanting answers to? How are they asking those questions? And then where are the answers located? And can you automate, the step between the question and the answer? When you look at, and we've probably looked at hundreds of deployed production chatbots over the last decade, and that fundamentally, the things people want to ask have not really changed in shape and form.
Okay.
It typically is, there are terms for these now. I'd say 50 to 60% of the questions are what you would consider needle and haystack questions. They are, I want this question, and there's an actual answer somewhere. You just have to go look it up and return it.
Okay.
That's what RAG is really good at. It's what Vector is good at. It's matching the query to the question. In the absence of a vector database, a lot of older technologies that companies have been investing in for decades, if not longer, things like Lucene search, are designed to do this, simple text matching, text similarity. And so, in fact, there's been research published about comparing the text matching performance of traditional techniques such as Lucene search to the new type of text search, vector search. And it's been demonstrated at least a year ago that there's no measurable performance difference.
Wait. I just want to pause on that for a second, because that's a very counterculture point of view right now. Everyone's in, vector paradise right now.
Right. And if we even discount Lucene performance and, give weight to vector performance, let's say vector is 20 to 40% better at needle and haystack search.
Okay.
When you look at the breakdown of question types, you're talking about a 2 to 3% difference in terms of the questions that get answered correctly or not, if you're talking about a 20 to 40% difference in needle haystack performance. So really, at the end of the day, they're not measurably better in terms of answering someone's question, in terms of the amount of question types that these techniques cover. If you look at the other 40 to 50% of questions people ask, they fall in roughly three types of other buckets.
Okay.
One is a relationship type question or aggregation question. Things like, I need to know how many times this happened, or tell me what documents this appeared. It's a question where you need to aggregate. It's really an aggregation operation that has to occur before the actual lookup. And it relies on relationships and connecting the dots between disparate relationships across document sets. And the way people are trying to solve this now is they're bolting on a graph database to a vector database, where the graph database maintains these relationships and helps you down select to the relevant documents where these relationships are described. Then you're doing a text search. That's one category of question. If you did that with 100% accuracy, you'd add 15% coverage of the total number of questions. People might ask your chat system, and you'd get from 50 to 60% to 60 to 75% correct answers to questions.
If I can, so I'd like to, correct me if I'm wrong, because I want to make sure
You're
I'm
wrong.
Completely. So first of all, like vector search, right? The whole idea of it is that you take like chunks of documents, right? So you take a document and you break it up into sections, right? And then you embed it with an AI model that turns it into a vector that summarizes in some way that entire chunk of a document, right? And what I hear you saying is that that's pretty good for things like needle in a haystack, because presumably if you're looking for like very specific questions, often when you do that, like if you're dealing with very specific information, it's probably in that little chunk, right? So then it hopefully ends up somehow represented in that vector such that you can search it. But when you're trying to do aggregate questions across a document, questions where you say which documents contain this type of information, you're not really searching for anything maybe like as specific. Would it be fair to say that you think vector search tends to decline in those types of queries?
I would say that any text matching strategy fails, and of which vector falls into. That's all vector search is. It's a new form of query to text matching. And by the way, when you embed your text, it's not doing a summarization operation. It's converting the text into numbers, a number representation of the text, matrices representation of the text. It's doing this, and when you do a vector search, you do the same thing with the query. You're essentially matching how similar is this matrices to, the database of matrices I have in my database using a mathematical technique, typically cosine similarity. But at the end of the day, it's a text search. And even if it's incrementally better than text search strategies that people have invested many decades improving and building, which I do not think vector improves on. But even if it did, it only solves this fraction of the total problems, the total question types that people will ask. You need a different technology or a different approach to accommodate the other gaps, the other types of questions that people ask, of which aggregation questions are one, and a graph database will help solve. It does not cover the other two major problems or the other two major categories of questions people ask.
So maybe you could walk us through that and explain your approach to solving those search problems.
Yeah, I mean, just to complete the list, the other two types are questions that are asked about a visual element, something like a table or a picture. There's not a lot of the information is represented visually. A human can understand those things. When you're doing text extraction, those things are lost. So it's basically the needle was never in the haystack to be found. There's no magical database or technique that will solve that problem. You can't improve your embeddings and find a needle that was never put into the haystack to begin with.
Okay.
The other category of problems really have to do with within the document itself. And again, a graph database helps to a certain extent, but a courtroom trial transcript was the first time I really saw this problem in an extreme fashion. But in a courtroom trial transcript, it's typically a 300-page Word doc or PDF that gets typed up by a typist. At the top, she'll put the names of the judge, the lawyers, the witnesses that spoke. And as you go through the transcript, the witness is referenced when the witness changes. Or the lawyer, the prosecutor or speaker is referenced when the the lawyer changes. And throughout the rest of the document, the people are referred to as Q and A. So if you were to say, like, what did witness A say, or what did witness Daniel say on July 4th, a graph database would help you find that transcript. But a graph database is unlikely to help you find the things that Daniel said in that day, because the reference to Daniel is made once early in the document. Daniel's referred to something different throughout the rest of the document. in a completely different way. So like this is again as a human shorthand. A human would read this top to bottom, the entire document. They might even scroll back up to figure out who Q&A was, but the important reference is early, and then there's massive amount of text way beyond the context window of modern LLMs, even if you wanted to stuff the whole document in. And the reference is early, and the references that rely on that reference, the statements that rely on that reference is lost when you chunk the document. So it's really like this important surrounding information around the chunk gets lost when you chunk these things into bite-sized pieces that can be stored in some kind of text database and retrieved. And then when you retrieve it, the text is missing all these important references and context. That is the other category of problems. And a graph database, if you were to bolt on a graph database to a vector database, and that's your solution for RAG, you're going to get to 70-80% coverage of questions. Assuming you're perfect at those, your system performance is 70 or 80%.
Right. So maybe walk us through how an RAG engineer would think about solving these challenges.
Yeah, so that's where we started. These are the questions people ask. This is their basic shape. You need to understand relationships, both across documents, within documents. There are important references that are made. There's a surrounding context to each chunk that you have to preserve to give it the complete meaning it needs. And, I credit Neil for this, but I think the simplest way to think of it is like when you chunk up your data, you've really got to consider each chunk a complete idea that stands on its own. And that's what you really have to create when you're chunking. And so when you think of like, this is what I need to create and retrieve in my retrieval system in order to cover all of these question types, then you start to think about, what's the best way to do this? Things like what section did a chunk come from are less important, still important to finding the chunk and giving meaning to the chunk, but it's less important than the chunk itself. So, the section it's from, the title of it, important, not as important as what is actually in the chunk. So if you were to just like write a narrative, complete idea of a chunk, that became your chunk, then it removes kind of this ability to weight the importance of the aspects of the chunk, the metadata of the chunk, its title, its section, the actual chunk text. They don't all have the same value. So that then your chunk has got to be a complete idea. It's got different aspects or attributes to it that have disparate values, different kinds of values.
Hold on one second. I want to back us up because you're sort of blending a bunch of things in. I just want to help people get it step by step.
Yeah.
The first problem you're talking about for doing RAG search well is you have to extract the information from the document correctly. We've done a whole kind of video on that prior about the different parsing techniques. Then you're getting into, I think, what you're talking about now, which is this chunking strategy. How do you chunk it correctly so that what you wind up with is each chunk is a complete idea? Maybe you could walk us through how a RAG engineer should think about how to do that chunking. Like, it's cool to say it's a complete idea, but how do you do that? And I think, GroundX is using a vision model plus some semantic rules, but how should a RAG engineer, if they wanted to build another GroundX maybe, how would they think about how to do how to do the chunking right, from your opinion?
Well, again, I always start from first principles, and we're on second principles now. What is the actual chunk, which is the idea and its metadata, which does not have equal weight. Then you can talk about like how to construct something like that, which is what you're asking for. And when you look at these documents, they really are composed of, doesn't matter what they're about, what vertical they're from. These things are meant to convey information to a human, and that's universally true.
Okay.
And when we do that, we typically do that with text, with visuals, and with tables. And if you go through these documents across all these industries, that you could reduce everything in these documents to those three things. So, and these three things need to be treated completely differently. Text is, text. It can lose some meaning if you lose, section titles, for example, or other important surrounding information by just splitting it. But then, tables, they're a hybrid text and visual format.
Mm-hmm.
I'd say 50% of the information is written, 50% of it is visual in the layout of the table. But then you have figures where 80% of the information is visual, 20% of it is text. So, if you were chunking it, the way that, and your idea of chunking is to capture the ideas that are represented in a document, and it's important metadata. Then, I start thinking you're creating three kinds of chunks within the document. You're creating text chunks, table chunks, and picture chunks, figure chunks.
Similar to what we have kind of visually here on the slide. The top one's a text, the middle one's a table. And
so if you were to create an automated way of doing this, you need an automated way of identifying text, tables, and figures, and distinguishing the three things from each other.
Mm-hmm.
That's why we've invested so heavily in figure models, table models that are able to detect these things in the wide variety of ways humans will visually represent these three basic things.
Yeah. So the approach you've taken to solve this identify problem, where's the table, where's the text, where's the figure, the graphic?
That's right.
Is fine-tuning a vision model essentially on roughly 1 million pages of documents that look like this, or look like medical, or look like insurance, or what have you.
And I'll be completely transparent. We use a Detectron 2 based model, of which arguably we've put significant data into. Some significant fraction of the data is our own at this point. Yeah. But there are new transformer models like Microsoft's table transformer model that add in additional transformer layering to the underlying detection model. We've experimented with those. They, I wouldn't say we can come to a definitive conclusion. There's a lot of options out there for doing these kinds of things, particularly with tables, because traditionally big companies have been interested in processing invoices and forms, which has meant a lot of investment in identifying what you could call tables, really forms and receipts. And so there's a lot of very sophisticated table models out there that perform adequately, perform a lot better with fine tuning. There are fewer figure models, very few actually, but you can take vision models and fine tune them and improve them and make them good at detecting figures in a document. That's what we've done with millions of pages of examples that we've invested in annotating.
So if I could summarize that for folks, and tell me if I have this wrong, if I could summarize this, there are we've chosen Detectron as our model to fine tune, and it's getting about 90% accuracy now on identifying the tables, the graphics, and so forth, the right position. Actually, when we see people send us like upload a single file in this testing called X-ray we have on our website, it's kind of astonishing actually what people find. Like someone can literally take a picture of like a toy box and still identify everything on it. It's pretty neat. But without tuning too much of our own horn, I want to explain the technique. You need some kind of typically a vision model, but you need some kind of model that can identify these objects on page. You then need to fine tune that model, or multiple models if you choose, towards the document set that you think you're going to encounter. And we chose Detectron. Things are moving fast. There might be other models that are better in the future, but the technique is still the same. You have to give it thousands or hundreds of thousands of examples of what you're after so that it can identify it consistently. And that's kind of the workload that's ahead for RAG engineers to kind of do this technique. Is that about right?
Yeah, so when you pull one of these table models off of the shelf, off of Hugging Face or wherever you're pulling it, this is a generalization, but it's going to find 50% of the tables, 20% of the pictures. the last time I looked, we're at 95% tables, 90% figures. And by the way, the data is not vertical specific. It has more to do with how people draw things. Right. And maybe it might be different in different verticals, but it's really showing a model, the variety of ways people draw a table or visualize a table, or, you know, the variety of types of pictures that really matter within documents. It's loosely tied to verticals, and more has to do with how humans choose to represent things. Because again, documents are a way for humans to communicate ideas with each other. That's not a vertical specific thing. It's a communication style. And that's why this problem is, when you go the vector route, the verticals and the text really matter to the embeddings and their ability to translate the text into a vectorized version of the text that matches really well with the kinds of queries that you're asking through vector search. But like, if you step back and like look at this problem from first principles, documents are, the fundamental construction of documents is not vertical specific. Right. Any kind of fine tuning specific to verticals has been completely tied to, you know, the strategy of using vectors and embeddings. But anyways, and you know, as an aside, I know that a popular technique these days is to just take pages and feed them into the multimodal models and ask them to convert them into JSON or Markdown. And you know, if again, that's better than what's been done, which is text extract and vectorize and store. That
is what's been going on so far.
It will work. It works better than that approach. It's an iterative improvement. But you know, if you think of your goal as being capturing ideas within text, and what you're doing is just taking pages and saying, turn this into Markdown, that like sidesteps the whole ultimate solution you're trying to create. You know, setting aside whether it works or not, which by the way, the models have severe ADD still. If you're to try to do this with something even moderately visually complex, it's going to lose a lot of information in the page. So it is, it's an iterative improvement. That's why we have invested so heavily in understanding where text, tables, and figures are within a page, because what we're trying to do is capture ideas and convert them into complete self-independent objects.
So if I can jump in, so it seems like when we started, one of the core ideas was vectors are good at finding stuff in needles in a haystack, generally. At least they're pretty good. Maybe they're not really much better than previous solutions, but they are good, right? It seems like one of the big problems of RAG is that the needles don't exist in the first place. I think you mentioned that. And one of those needles is visual information. And it's visual information that I think humans take for granted, right? You look at a text document and you go, it's just a bunch of text. But really there's formatting, there's separation, there's the way the text is structured can actually be really visually complex, right? So taking the textual information out in a way that kind of preserves that sort of spatial stuff, taking out tables that also preserves that spatial stuff, taking out images that preserves the spatial stuff, and also things like colors. Like if you have a graph and something's orange, you have to know that it's orange so that you can answer a question about it, right? It seems like the first step is being able to grab these things and take them out of a document so that you can process them independently. I'm curious. I think it'd be nice to go through the rest of the pipeline, because I think that first step of you get things out and you can individually play with them. I think that's like an important first step, but that's not the only thing we do, right? We do a lot of stuff after that. Maybe we can talk about, real quick before we wrap up, things like the modality grounding that we do in terms of re-representing. You also mentioned another problem with RAG is that you have like these information that's disparate throughout the document. How do you try to rectify that? And I believe we use basically baking in context using a variety of approaches. Maybe we can kind of blitz through that pipeline before we wrap up.
Absolutely. I would like to say, though, that while this linear view of how data flows from start to end and what the end is kind of why the architectures for RAG exist today. And, you know, I walk through how we thought of it because I think it's the right way to think of it from the ground up. And then you create a system to produce the thing that you believe needs to exist. And that's how we've done it. And, you know, and just to finish that before I give a linear walkthrough of how it happens, you know, the way that we preserve information about an idea that's important from surrounding parts of the document or disparate parts of the document, we do a lot of repair of the chunk using what we understand about entities and relationships within the document. We include in every chunk document-wide understanding of what document this chunk lives. We give each field a weighting, and this is the object that gets saved into a Lucene-based search database. And we do a weighted field query search across the object in order to find the relevant chunks. And then what we return to an LLM are complete ideas that chunk represents, and that's what's used to create the completion. The way that it happens is we have APIs and no-code tools where you can take a document as an end user. This is your experience with everything I've just described. And you upload a file, either as binary data or a hosted URL through an API, or you drag and drop a file into a folder through a no-code tool. And then it goes through an ingestion pipeline that begins with, you know, basic validation, uploading the document, saving it, then running it through a visual layout analysis using the vision models I've described, finding the tables, the figures, and the text. It does OCR extraction when necessary as well. And what we do is we bundle up this information. This is where all the text, the tables, and the figures are within the documents. That goes back to the next step in the pipeline where we try to reassemble these different elements into coherent sections of the document. Has to do with, you know, looking at, you know, largely heuristic based, because the way that humans lay out these documents is heuristic based. It's outlines and skeleton, you know, there's a structure to pages, loose structure to every page. And we use these human heuristics for how we communicate ideas within documents to help us construct different sections of the document. Then we create for the whole document a set of metadata, search keywords, summaries for the document, important entities and relationships within the document. Then we do the same thing for sections, important entities within the sections, a section summary. Then we go through all the chunks and we do the same thing for the chunks. You know, and we do something we call repairing the chunk or complete fleshing out the chunk. If in the case of text, it's really add in any, you know, replace any abbreviations with their full name, things like that. Add back in the section title. You know, fill in the pieces that were missing that gave this text meaning. With tables and figures, it goes through a multimodal processing, and you know, it's a 3 or 4 step process in each case. But a paraphrase of it is, you know, take this table, create a template for it that's going to really capture all the information in this table. And then we apply that template to the table repeatedly until all the information is converted into this template. Similarly for a figure, we're basically doing a series of chain prompts using fine-tuned LLMs that create instructions for itself to reprocess the chunks into a format that we think is ideal for an LLM. And then in each chunk, we take this repaired version of the information, the encapsulated idea. We wrap it with the document information, the section information. Those are each searchable fields that get saved into our Lucene search. And then we apply weights to these different aspects of the chunk when we do a search. So when you're searching for, find me references to Daniel when he was in arrested for DUI.
Which shouldn't happen, by the way. I'm squeaky clean. Kind of boring, actually. I wish that happened to me. That sounds like I at least go out. I suffer from your problem of being in basements.
We do a weighted search.
Dan, I'll get to you.
Where if you gave equal weighting to the document or the day the document was created to what the text was within the chunk, you would get all the chunks from the document back. And, there would be no nuance to which of these chunks actually has that answer. That's why, doing a weighted search across these fields, while it's important to find the right chunks and to return the right idea, it can't be strictly done as a simple, similarity match. It's a weighted search. And so, I started with why we did this and the thought experiment, and that's all driven the technology choices we've made. And it's fundamentally why I think the approach people have taken is wrong. I think they're following best practices that were promoted when this all happened, and how-to guides on how to do this, and not really thinking about what they're trying to achieve and for the user and what the best way to achieve that is, which is what we had to do and why we have turned out so differently.
Yeah, it sounds like this idea of, looking at documents to extract visual information, and then also this idea of, re-representing that in a grounded textual modality, and then building templating on top of that to basically say what information should exist to describe this thing, and then using an LLM then with a cocktail of contextual information to fill out those templates, basically getting the system to create prompts for itself based on the information that exists. And that being I believe it's called a semantic object, right? It's an object it's a template that contains all the information. I think this idea of doing so much work before search is directly antithetical to the common wisdom, which is you just get the data and then you do search on it. And then the search is real complicated. It seems like EyeLevel, it's basically the opposite, where if you set up the data really, really well and you pack everything really, really nicely, the search is actually the trivial part. We had a conversation before this, which I think was really interesting, right?
Sorry to interrupt, but there's one nuance on that. The search is trivial. It's, doing a multi-field weighted search is not new. Mm-hmm. What is new is that no one's doing it because they've been told to do it using vector databases, which are not built to do this. They're built to do simple field matching, text matching to query. So with that one nuance to what you said, it's true. It's all about capturing complete ideas and then searching them effectively the way that they need to be searched, not as a simple match, but as I said, a weighted query.
Yeah, and so we were talking before this, and I think this is really interesting, right? Vectors are all over the shop in AI, right? They're everywhere. It's the language model that you're using to run the generation is vectors. It kind of naturally, right? We have these vector embeddings, and we have these large companies making models that deal in vectors. We have big companies that are selling endpoints for turning your documents into vectors. You are using language models that are all vectors under the hood. You have vectors, 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 vectors all over the place. Do you think it's fair to say that a big reason vectors became the center of RAG was really out of habit in terms of the growth of AI? It kind of got swept up and the momentum rather than any implicit merit. Do you think that's a reasonable kind of conclusion to make?
It goes back to how we started this story, with our history, and how there was no investment in chat, anything with the word chat was a non-starter. So ChatGPT comes along and suddenly everyone wants ChatGPT. like it happened overnight. It was like a 180 shift in terms of interest. I've actually used the analogy. We were out trying to catch a wave. We're the last surfer out in the water. Suddenly the biggest wave that's ever existed on the planet comes along. So everyone on shore grabs a board and starts paddling out to catch the wave. That's what it felt like. And when this happened, there were no mature technologies people could pick up and use. And that everyone wanted to do this, and there was nothing there. And the reason is there was no investment. Our company was not ready for this. What happened? We expected it to happen with GPT-4, which came 6 months later. We're caught completely off guard. There was a Series A company, Pinecone, that was, on life support trying to sell a vector database. There was an orchestration tool with very few stars on GitHub called LangChain. That's what was there. So, and then when you use
fired, by the way.
When you use a vector database, you have to use embeddings to create the vectorized representation of your text. So there's a economic incentive to the company who brought you ChatGPT promoting using embeddings. Like they make money off doing that.
It's a vector mafia, man. It's a vector conspiracy.
Well, these are the realities. I understand why it happened. Like people picked up what was there and what got promoted by the company who brought this magical thing to us. It's not probably widely known, but OpenAI had a RAG API that they sunset 3 months before ChatGPT took off. It was called Answers API. And when they sunset it, they open sourced how they did it. And I read the source code. I still got it saved on my computer. They wrote a blog post describing it. A month later, they deleted it. I don't know why. I saved it. I can't find it anywhere. Anyways, they were using a Lucene search, no vector embeddings, for their RAG endpoint that they sunset 3 months before.
These are deep reveals. I feel it's like how they buried the first electric car or something. This is like when the story is fully told, this documentary is going to be deep.
They did use a re-ranker as well. And we use a re-ranker, and it's loosely based on what they open sourced. Both their Lucene search and their re-ranker were pretty primitive. I think the decision they made was RAG is really a data engineering problem. They're a data science company, and they couldn't be two things. So they sunset it. But when they invented RAG, they invented it the way that we did. When they promoted RAG, they promoted it as a vector problem. And, that's why we are where we are.
Which they make money off of by selling vector embeddings.
That's right.
I think they're doing okay, actually. It's OpenAI companies. They're doing it.
They're suffering through.
The right technology doesn't always win. There's a lot of inertia around vector. You will have to bolt so many things onto a vector database to make it do the things I just said, because it was the wrong thing to pick from the beginning, that you're going to end up with 3 databases, really: a meta database, a graph database, and then the vector database. And then it's like, why did I pick the vector database to begin with? A Lucene search, all 3 of those things combined into one.
You are describing how a lot of people are now building these advanced RAG. I mean, you're kind of describing a lot of advanced RAG there, actually.
That's right. They're bolting things onto the wrong thing. That's what's happening. But there's a lot of economic inertia in that. Like, there's a lot of investment, and it could still win. I mean, was VHS better than Betamax, or which a RAG approach did the porn industry pick?
That's
a good question.
Well, I'm going to go check RAG Hub, and actually sounded even weirder than it was meant to be. On that note, we've covered a lot of territory, and Ben, I thank you very much for coming out of, well, not even leaving I'm actually super grateful you didn't even leave the basement. Daniel, thankful for smuggling on camera into Ben.
It's my pleasure.
And thank you for joining us on RAG Masters, and hopefully you'll come back, and but not for like a couple of years. You got to get back programming stuff.
Thanks for having me.
Thanks, Ben. See you soon. Daniel, as always, I was going to have an epilogue here, but like a little bit of a stick here at the end, but like we're at 50 minutes. So let's just say goodnight to everybody and see you guys next time on Ragmasters. Thank you.